competitive examination taken by millions of students every year in India. This was the February 2016 Computer Science Information Technology paper. It is a question on the theory of computation. Here is the problem. GATE Computer Science and Information Technology 2016 examination, February 2016, paper 2, question 16. It's a fill in the blanks question. The answer has to be a numerical value to be found. Here is the problem, question 16. The number of states of a minimal size DFA that accepts the language defined by the regular expression 0 plus 1 star, 0 plus 1, 0 plus 1 star is that. You have to find out how many states are there in the regular language denoted by this regular expression. Let us study this regular expression. It says 0 plus 1 star start with. That is any string followed by 0 or a 1 followed by any string. So beginning and end can be anything, but a 0 or 1 should be there in the center. We use first of all a famous theorem called Hero's theorem to see whether we can get the number of states of the DFA which accepts the language denoted by the regular expression. We shall take the input and we will partition the set of all inputs into equivalence classes. Let us study the regular expressions. It says 0 or 1 is compulsorily in the set. So empty string is not allowed in the regular language denoted by the regular expression. The empty string is not to be accepted by the NFA or DFA. The start state cannot be a final state. So one equivalence class is epsilon. The first symbol has to be a 0 or 1 in the string. Now, after the first symbol, everything is in the same state of the finite automata, which can be built from the regular expression or the regular set denoted by the regular expression. So one equivalence class is required because epsilon is not in the language. And after the symbol 0 or 1, one more state will be there in the finite automata. So one more state is required. So we'll require one more equivalence class. The equivalence classes are therefore epsilon and all strings but for epsilon. The second one is a final state. So the answer is 2 states are required for the finite automata. The first state is non-final, second state is final. So the answer is 2. Let us try a more user-friendly way of doing it. Let us work out the problem using the long way as per the standard theory. We will start with the regular expression. From the regular expression, we will construct a non-deterministic finite automata NFA accepting the language denoted by the regular expression. So too many epsilon moves will not come in the NFA of the epsilon moves. We'll take shortcuts. We'll cut down the epsilon moves as far as possible. From the NFA, we'll construct a DFA by subset machine construction procedure. We'll minimize the resulting DFA to find out the minimal DFA. Then we'll count the number of states of the minimal DFA we obtained. Here is the regular expression. 0 plus 1 star, 0 plus 1, 0 plus 1 star. Let us construct the NFA. Of the home state, 0 or 1 I remain in the same state. Set of all possible strings, 0 plus 1 star. 0 or 1, I go to another state C. We call the class, home state, class state. 0 plus 1 star, I remain in the final state. So the home state is 0 plus 1 star, transition is 0 plus 1, this one is 0 plus 1 star. This is the final state, the start state. From the NFA, we can construct the DFA. Home on 0, go to home class. Home on 1, go to home class. Home class, remain in the home class. For 2 states, start state H, final state H, C. Now to obtain the minimal DFA, we'll color the states of the DFA. First, we'll take one color for the non-final state, one color for the final state. Then we'll try to apply the partition algorithm. In this case, we don't require it. There's only one color, one state non-final, one state final. We cannot reduce it any further. So what we have is we require two colors to color the states of the DFA. The answer is 2, and the final DFA requires two colors only. So we partition the states into two states, final states, non-final states. One color is required for final state, one for non-accepting state. So one partition contains the final state, one partition contains the start non-accepting state. The start state cannot be a final state, so epsilon is not accepted by the DFA. The answer, therefore, is 2. End of the presentation. Thank you for your attention.